I'm a professor at the University of Wisconsin-Madison. I've been working with Novik, I've been working with plant breeders, and one of the questions that I had too was, what really is happening when we're breeding for organic systems? What specifically are we targeting, or should we be targeting? So as kind of an offshoot of that work, along with a graduate student of mine, Michelle Keller-Pearson, and a professor in bacteriology and agronomy, Jean-Michel Hannay, we started to embark upon this project, which was looking at symbiotic outcomes for carrots and soils inoculated with arbuscular mycorrhizal fungi. So again, this is really came from the work with Novik and some of the questions that arose from Novik. We know that there's an increased interest in breeding for organic production systems. We've seen that when we trial in organic versus conventional systems, particularly with specific crops, there can be rank order changes with respect to the top performers in each system. So something is happening specifically with organic production systems that can cause a difference in performance. And one of the traits that we could potentially be looking for when selecting varieties for organic production systems is the increased ability to access nutrients under organic management. Not necessarily that organic management is a low input or fertility limited system. It can indeed be that, but with organic inputs, the availability of nutrients can vary throughout the system. So the ability to access nutrients consistently throughout the system may be more important even in a highly fertile organic environment. And one means to achieve the goal of more ready availability of nutrients, more readily accessible nutrients, is through arbuscular mycorrhizal fungi. So arbuscular mycorrhizal fungi are species of fungi that are living in the soil, and they form symbiotic relationships with certain crop species. It's actually still fairly uncertain as to the scope of specific species that arbuscular mycorrhizal fungi form associations with. It's an assumption that most brassicas do not form associations with arbuscular mycorrhizal fungi, but most other crop species do. And within these symbiotic relationships, the fungi benefit through the carbohydrates that the plant produces through photosynthesis. So the arbuscular mycorrhizal fungi can, for lack of a better description, infiltrate through the roots. They can access the carbohydrates, and in turn, through the symbiotic relationships, the fungi then improve the plant's access to certain nutrients and water as well. So it's essentially a expansion of the root system. So particularly phosphorus, arbuscular mycorrhizal fungi help plants access phosphorus, to a lesser extent nitrogen, and also through water. So as well as through access of nutrients, one of the goals in terms of looking at increasing mycorrhizal fungi associations is improving resilience, especially in drought conditions, that arbuscular mycorrhizal fungi can help the plants access water in water-limited conditions. Interestingly as well, from the water component, arbuscular mycorrhizal fungi and fungi in general are critical in terms of producing glomalin, which is a specific protein that is exuded by the fungi, again, for lack of a better description, that can help with aggregation and the binding of soil particles. So it can help with the water holding capacity of the soil. So fostering these relationships and fostering these arbuscular mycorrhizal fungi may directly help with water availability through, again, these extensions of the root systems, but also may indirectly help with the water holding capacity of the soil. There's also, so as well as being a professor and doing research in organic, I'm also the state extension specialist. So I work with a wide array of farmers throughout the upper Midwest. And one of the primary questions I get, both from experienced organic farmers as well as transitioning organic farmers, is what is the value of all these soil health enhancers, that these different products that are available, these microbial products? So even beyond the organic community, these products are being more widely sold to the conventional community as well, as there's an increased emphasis on soil health and an increased recognition of the role of soil biology in terms of fostering a healthy soil ecosystem and a healthy soil status. So with that recognition that there's farmer interest, industry is taking advantage of this, and increasingly, again, these products are on the market. So in tandem with evaluating the role of these systems in terms of organic breeding, or the role of these products in terms of organic breeding, we're also more generally interested in what is the consistency of performance of these different arbusculum mycorrhizal fungi inoculants. So when we look at plant responsiveness to arbusculum mycorrhizal fungi, there's been numerous studies conducted over a wide range of essential crop species that do already indicate that plant genotypes vary in their responsiveness to AMF. So this is not necessarily a novel question, nor is it a question that doesn't have research to support different hypotheses. There's also been, in certain research, a documented loss of plant response to AMF from older genotypes to more modern cultivars. So one of the hypotheses is we breed in conventional systems under high input environments. As I mentioned, these relationships between the arbusculum mycorrhizal fungi and the plants are symbiotic, but they also, under certain conditions, can be parasitic. So if a plant has ready access to nutrients, it's a loss to the plant to supply that carbohydrate if it can get those nutrients in other ways that it doesn't have that cost of energy. So if we're breeding in high input environments where we have a ready source of nutrients, there may be a rationale for the plant to basically shut off the ability to make those connections. And indeed, plants have mechanisms in which they can do that. So as we look at this body of research, what we find is indeed the trends are variable. So for instance, with wheat, research has found that the modern varieties of wheat compared with older varieties, ancestral varieties, and land races demonstrate a loss of positive response upon colonization of arbusculum mycorrhizal fungi. So what was found was that the ability to host mycorrhizae declined in wheat cultivars bred after the 1950s. In part, it was thought due to the increasing levels of soil fertility in breeding programs, making such symbioses unnecessarily, again, moving into a parasitic relationship versus a symbiotic relationship. Conversely, though, corn genotypes across a range of release dates actually showed that mycorrhizal fungi associations were not negatively impacted by selection, and that the AMF may actually promote the growth of modern varieties in high P soils. So again, there is a body of literature available, but it's not necessarily consistent. There's also, again, confounding the story even further, is that differences exist between AMF strains. All AMF strains are not created equal, and all AMF genotypes are not created equal. So there's a wide range of different genotypes of AMF that are present, and they can actually differ too in terms of performance depending on where those AMF species are isolated. So AMF may be the same species and strain or species between North Carolina and California, but their performance can be different depending on where those strains were isolated. Which again, from a very practical extension perspective, is very important to farmers, because there can be, even though they're sold an AMF product, there can be quite a difference in response to that AMF product depending on what specific genotype of AMF may be contained within that specific product. So our hypothesis within this study was that modern hybrid cultivars bred under high input conditions will exhibit less benefit as measured by plant above and below ground biomass from AMF inoculation as compared to older open pollinated heirloom cultivars, which had a greater evolutionary need for these soil symbionts. So we chose for our study to use carrot as the model crop, in part because we've been involved in a project with Dr. Phil Simon looking at breeding carrots for organic systems. The carrot genotype the carrot genome has been sequenced. So we had a lot of access to really a good carrot knowledge, some good carrot resources. And carrot was also, in some of our earlier studies, included within the Novik project. So it fit well in terms of our ability to grow the crop and the resources we had available to conduct the research. We also were interested in learning if specific AMF isolates may confer different magnitude of advantages, particularly under stress conditions. So in each of the fields, which are on certified organic fields at one of our research stations associated with the University of Wisconsin-Madison, we picked fields that had a low phosphorus status, and we also had treatments that were water stressed. We grew the plants under caterpillar tunnels, so we were able to exclude rainfall, and we were able to impose stress upon the plants. So again, our goals were not only to better guide potentially organic breeding efforts, but we also wanted to start to begin to develop best management practices with respect to AMF inoculation, again, in response to the farmer questions, when are these products useful, and are these products useful at all? So materials, again, we chose 2 open pollinated heirloom varieties, red quartz Chatonnais and scarlet nance, 2 hybrid varieties, Napoli and Nelson, very commonly used by organic farmers. A mock inoculant, we wanted to make sure that our inoculant wasn't actually having an advantage in of itself by allowing more nutrients to the plants. And then we had 4 different species of robusco mycorrhizal fungi from 2 specific geographic locations, California versus North Carolina. So we had, again, well-watered versus drought caterpillar tunnels. We had 2 planting dates each year over 2 years. So we essentially had data from 8 separate caterpillar tunnels. We had 3 replicates per tunnels. We randomized and blindly and blind inoculated the plots. And so we had 9 inoculations times the 4 cultivars, and we had 36 treatments. So there are a lot of treatments. This is a photograph of those caterpillar tunnels, irrigated by drip tape. They were well watered during establishment. During taproot maturation, the carrots were imposed by water restriction. And then 10 marketable carrots per plot were harvested, weighed, and measured. So we did overseed, and then we did thin, so that we were trying to take away that variable of planting density for root weight. So here's the results. So here we have our heirloom cultivars, scarlet nance and red quartz Chardonnay. Here we have our hybrid cultivars, Napoli and Nelson. Here we have all our different strains of AMF. So what did we find? This is the same data essentially. So here's our, the animation didn't work. So here's our, these are our open pollinated cultivars. These are our hybrid cultivars. So, and these are different AMF treatments. So essentially what we're seeing here is that anything that you see highlighted in green was a positive response to AMF inoculation. Anything that's not highlighted is a neutral or negative response. So essentially what we're seeing is that the open pollinated varieties, you can see a lot more highlighted green in here, which is indicating that overall across 4 different experiments, we're seeing a lot more positive response to AMF inoculation versus our hybrid cultivars, which you do not see as many green boxes here, so not as much positive response. We did see, we did check for colonization, and indeed we did see colonization of each of the different AMF species and strains, but there was no consistent response to any particular AMF species or strain. They all had a fairly similar performance. None of them were excelling versus any other AMF strain. So our conclusions from this particular experiment, the OP versus hybrid cultivars of carrots, did appear to differ in the response to AMF inoculation. When we look at breeding, I think we can, at least with carrot, consider that the selection environment and strategy may be important in terms of evaluating for AMF response. And many factors need to be considered in the evaluation of AMF inoculants for field production. So when farmers report that there's an inconsistent performance upon AMF inoculation, some of it may be due to the particular cultivar that they're growing. So again, there's a lot of variability in terms of how these products perform, but there's a lot of factors that can be considered in terms of where that variability is coming from. Some acknowledgements. Again, Michelle Keller-Pearson is the PhD student that has been doing most of the work. My collaborator, Jean-Michel Hannay, who's an expert in Responsiveness mycorrhizal fungi. There's been a long list of undergraduates that have helped with the work. My technician, Dylan Bruce. And this project has been funded by a variety of mechanisms, including the USC OREI project. In large part, Michelle was funded by a National Science Foundation Fellowship, as well as the SciMed program. And this is also, in part, an offshoot of this project is funded by OFRF, so we'll be really excited to see what those results yield. And that's going to look at more of an on-farm study to evaluate how these different cultivars recruit native species of AMF, which is not really something that's talked about, how, in terms of the broader ecosystem, how inoculation with these exotic strains of AMF may be competing with some of the native strains and maybe potentially introducing a non-native species to our organic farms, which we don't necessarily consider, probably because it's not as evident as other non-native species such as weeds or insects. So with that, I don't know if I have time for questions.
You have 5 minutes for questions,
okay.
Yeah. Thank you.
Yeah, in your, what was the actual response to inoculation on the carrots? Was it quality, quantity?
So we measured root weight as a key trait, so just how big the carrot root was, as well as the shoot weight as well. So measuring the overall growth both above and below ground. So essentially a yield response for.
Did you do any quality measurements?
We didn't do any quality measurements. We did try to collect some data. I think this is a data set that we'll have to see if the student is able to integrate within her dissertation, but looking at carotenoid levels. So we did do some HPLC analyses to see if carotenoid levels varied upon inoculation, but she hasn't looked at that data in depth.
I have a probably stupid question, but don't know anything about this, but just speculating, does AMF, if you had non-organic and organic farms, and the use of pesticides and obviously the differences between those farms, would AMF populations be lower? I guess I'm getting at more, is AMF one characteristic for establishing soil health in organic systems?
In terms of AMF populations, I mean, that certainly is a question, particularly with heavy applications of glyphosate, whether or not we're altering the microbial communities and are those populations depressed within conventional systems. I think the data varies. From the data that we've collected off of a long-term cropping systems trial that's on UW, we don't necessarily see that. It does alter the profile of the communities, so which specific types of organisms within each class, but it doesn't necessarily depress. So it changes the profile, but not necessarily the absolute numbers. If anything, I think tillage and then fostering strong, diverse root systems tend to be more important in fostering AMF.
Our parallel evaluation of biostimulants involves care as one of the crops. Heights on the ground, spring and fall. Instead of using multiple varieties of carrot, we were using multiple inoculants, all commercially available. Can you speculate on what, as to why you might be getting the responses that you showed in terms of the older cultivars, the OP cultivars being more responsive? Is it root architecture? Is it what is it? If you care to share, what is it we're thinking as far as the basis for that response?
Yeah, and that would be, and again, this is just it's a fairly limited study in scope where we focused actually more on replicating the different AMF strains. And my hypothesis would be similar to the wheat story, that that breeding under high input conditions potentially would have shifted the relationship into more of a parasitic relationship, and the plant may have lost its propensity to form those associations. Why that may be differing versus the corn data that had been published, that there wasn't that same sort of response, but that tends to be the best, or the most common hypothesis is it's due to the high availability of those nutrients in conventional programs.
But presumably that signaling would start even, presumably that signaling for host, and microbe interaction recognition, that signaling would begin very, very early, to determine whether or not we're going to make a match, right? Is it before it even becomes parasitic or symbiotic?
Yeah.
Is it, and I'm just speculating. Is it
the
architecture? Is it the exudations? Is it chemical? Is it physical? Probably a combination of both.
Yeah, that's a good question, whether it has something else to do with the root system that changes between the, which we don't know. Then those are good questions to ask. One of the other things that there was also some parallel greenhouse experiments here, and again, looking at best practices, one of the things that was noted is that potentially if farmers, particularly organic vegetable farmers, were trying to find more consistent response, that more consistent response could be found by using those inoculants in greenhouse setting and starting it in the transplant. So maybe that's that early signal and more of that direct contact with the root system early on, because there seems to be, in evaluating the literature as well, more consistent response when applied in the greenhouse versus these field inoculation settings. So how that then is due to some of these early signals and competition and potentially some aspect of root exudates.
Thank you, Erin. I can just take that from you. Yeah. Thank you so much.